Unit 3, Day 1. In this lesson, we're going to talk about y equals 1 over x and about horizontal and vertical asymptotes. In the warm-up, we're going to need to use something that you've used in the past. If you're going, let's say, 30 miles every 1 hour, 30 miles per hour, and you go for 2 hours. That means every hour you go 30 miles and you go for 2 hours, then you're going to go 60 miles. Right? Well, the units above and below reduce out, and we're left with miles. And 30 times 2 is 60. And this is a rate, how fast you're going. This is a time, how long you traveled. And this is a distance, how far you've gone. Rate times time equals distance. So in the warm-up, we have a distance. And in the directions here, we have a rate, 8 miles per hour. So rate times time is distance. Here's our rate, the time we don't know, and here's our distance. To solve for t, we divide both sides by 8, and we're left with 8/10, which is 1.25 or 1 1/4, which is an hour and 15 minutes. If we have an unknown rate, we still plug that in. They ask for how long, so we're solving for time. So again, we divide both sides by r to get the t by itself, and we get t over r. And don't forget the units, we're talking about hours, because the rate was in miles per hour. In this case, we have somebody else who's going 45 minutes, but since we're talking about hours, that's 3/4 of an hour. And so we want to know the rate. The distance is the same for both. And so here's our time that we want to use. We want to solve for the rate because we want to find the rate. And so we divide both sides by 3/4. Well, dividing by 3/4 is the same thing as multiplying by 4/3. And we get 40 over 3 miles per hour. You can divide that out if you want to. That's 13 1/3 miles per hour. One last use of this formula. We want to look for the average rate. Looking for the rate. Our time is t. The distance here is still 10 miles. So we divide both sides by t to get the r by itself. And we get t is 10 over t miles per hour. Again, don't forget the units. So we're going to graph this. So we'll say that y is equal to 10 over x, but r is x and t of r is y. But if x is 1, notice the scale here. Every box is 2. So if r is 1 or x is 1, we have 10. If x is 2, we have 5. If x is 5, we have 2. And if x is 10, we have 1. So then the domain deals with r, or the rate. And so if we're going to go someplace, we're not going to include 0, because if we go rate 0 miles per hour, we'll get nowhere. And we won't ever quite get to infinity for our rate. In fact, probably there's a reasonable rate maximum for a person, but we'll go to infinity for this graph. Since the 8 is with the rate, and we're looking for the time, this expression is the time to travel 10 miles at 8 miles per hour. This is going to say the time to travel 10 miles at 0 miles per hour, but if you're not going anywhere, you're not going to make the 10 miles, so that's impossible. It doesn't make any sense. If you look at the graph, as r gets closer and closer to 0, the graph goes up, or the y value goes up, or the t of r goes up, or the time goes up. So for part D, as r gets closer to 0, then the t of r, the time, gets higher and higher. As the rate gets slower and slower, the time is going to be longer and longer to go the same 10 miles. So as the r, or the rate, goes to 0, the time is going to go to infinity. On the other hand, as the rate gets larger and larger and larger, and you're still going to go 10 miles, obviously the time is going to get shorter and shorter and shorter. So the rate is increasing, and the time is getting smaller and smaller and smaller. So as we study 1 over x, and we plug in numbers here, notice that as x is getting larger, the 1 over x is getting smaller. And conversely, if we do the table backwards, we'll get the same kind of result. In both cases, 1 over a small number is big, and 1 over a big number is small. 1 over 1 is 1. 1 over negative 1 is negative 1. Some things to look at as we look at this graph. So as we sketch this graph, we first of all have the black graph, which is y equals x, or f of x equals x. Then if we take the y values and plot their reciprocals, 1 over x. So then this point, 2, 2, becomes 2 and 1/2. This point of 8, 8 becomes 8 and 1 over 8. Same is true over here. This point of negative 2, negative 2, if we take the reciprocal of negative 2, it's negative 1/2. And that's why we get this point. And that's why we get these two blue graphs. As x is a big positive, y is a small positive. If x is a big negative, the y is a small negative. If the x is a small positive, the y is a big positive. And if the x is a small negative, the y is a big negative. It's the reciprocal. So we want to give the domain. So going left to right, what are the possible x values? And so we go from negative infinity to infinity, but we can't plot 0 because 1 over 0 is undefined. The same is true for the range from bottom to top, and again skips over the 0 for the range. From left to right, if you look at it, the y values are always decreasing, but there's a jump from this part of the graph to this part of the graph. So from here to here it's decreasing, and from here to here it's decreasing. we can't say the whole thing is decreasing in one interval. We have to break it up into two intervals. So for concave up and concave down, one way to look at it is the cave is going down here from negative infinity to 0, and the cave is going up here from 0 to infinity. Another way to look at it is if you're driving on this road, you are making a right-hand turn the whole time. Right-hand turn, right-hand turn. That's when it's concave down. This one, from left to right, you're making a left-hand turn the whole time. And a left-hand turn is concave up. When we talk about end behavior, we talk about the right end and the left end. So the right end is when we go to infinity, and the y value is getting smaller and smaller and smaller, going to 0. Going to negative infinity is the left end, but still the y value is getting smaller and smaller and smaller, or closer and closer to 0 from below. Now this one's a little different. We can talk about approaching 0 from the right and approaching 0 from the left. If we approach 0 from the right, we're approaching it from the positive end. And if we approach it from the left, we're approaching it from the negative end. So that's what this means. As we approach x from the positive end, it's going to go up, infinity. But if we approach 0 from the left, it's going to go down to negative infinity. So again, plus from the right, negative from the left. So this is what the graph approaches horizontally from the left and right. So that horizontal line is y equals 0. On this line, y is always 0. The graph approaches this vertical line and this vertical line, which is that one vertical line, and that's x equals 0. Approaches it but never touches it. As MC Hammer would say, you can't touch this.